this is what the backside of one of our molds looks like. This is where the plastic is actually injected into the mold. It's a two-piece mold, two different halves that clamp together. This metal piece here is attached to both halves of the mold to keep them together when it's being stored and when it's being moved into position into the machine. Up here are electrical connections for what they call hot runners. So hot runners actually electrically heat the inside of the mold. The plastic is already coming in at, say, 450 to 500 degrees Fahrenheit, but it cools off real fast as it fills different channels in the mold. So the hot runners keep some of those channels hot. Another way the temperature is regulated is we've got hot and cold water running through both halves of the mold. And there's different temperatures for different jobs. So this is where some of the leaks that we have to deal with come from. Here's a much larger mold. You can see it's got an opening on the back side as well where the plastic gets injected in. Now we'll go over to a machine so you can see the nozzle at the end of the barrel where the plastic gets injected. So we had a bit of an incident with this mold here. You can see the backside where the plastic gets injected. This should not be here. This is leftover plastic. It had a little problem and ended up filling the cavity that the nozzle tip end of the barrel goes into. There is a wall, steel wall on the machine that separates the platen that this side of the mold is bolted into, and the nozzle goes into the mold and injects plastic. You can see that's where the material comes in. There's the material. There's a barrel underneath this shroud. The shroud's there to protect because it's so hot. It's about 500 degrees Fahrenheit. And then there's this purge shield here. You can see the nozzle tip. It's very hot in here. And if you look down there, in that cavity is where this tip gets moved to and ejects. That's the back side of the mold that's in the machine right now. This area had filled with plastic, black plastic, and it had hardened. And we couldn't remove the mold from the machine to change it out until we did something about that. So I heated it up with a propane torch 3 times. Eventually I just caught it on fire. It took a while for it to get hot enough that it would get soft enough that it would melt to the point where we could scrape it out with some metal tools enough so that the mold could be removed. So it's called blowback. Either the nozzle isn't seated all the way up against the backside of the mold, or the tip of the nozzle is not fully threaded in. This is what a nozzle tip looks like. The purge shield has a switch on the hinge. The machine knows if it has been opened, and if it is, the machine shuts down to prevent somebody from getting hurt. And that's how we ended up with that. The tool and die guy will take care of that tomorrow. Thanks for watching.